In this unit, we are going to look at 5 different families of chemical reactions that have predictable outcomes based on the types of reactants that we put together with each other. And the first family of reactions in this series are a grouping called synthesis reactions. To begin our study of chemical reactions, we're going to use a people analogy to help us understand how reactants become products. And for the purposes of this analogy, I'd like to let some little gentleman people represent metals, and you can see them there as the yellow and blue characters. And we're going to have some non-metal characters as well that are represented by little ladies that are red and green. And so to sort of model synthesis reactions from a relationship type of standpoint, we're going to begin by looking at a couple of different scenarios. The first scenario is what happens if you have a nonmetal reacting with another nonmetal. Well, we know that two nonmetal elements can come together to form a type of compound called a molecular compound. And these compounds consist, of course, only of nonmetals, and those nonmetals are bonded to each other via covalent bonds. Another situation we might have in a synthesis reaction is a metal element combining with a nonmetal element. And when these two elements combine, the metal can lose electrons to the nonmetal, and we end up with an ionic compound. Of course, the type of bonding inside an ionic compound is via electrostatic charges. We could look at the possibility here of putting a metal together with a nonmetal. However, metals don't tend to bond to each other. They have no means of sharing electrons like the nonmetals do, and therefore we can't react metals with metals. We can create mixtures of metals instead, but this results in no reaction. So this is not one possibility that we will explore in this unit. Another situation we can have, especially for the 3Us, is we can have a scenario of a non-metal oxide. And so a non-metal oxide is some non-metal element combined with oxygen to create a compound, a molecular compound. And when that non-metal oxide reacts with water, which I'm going to write as HOH for the purposes of this unit, and you'll see why as we go through it, we end up with a substance called an acid. And the general formula for an acid, of course, especially for the grade 11s, is something that has H plus combined with some other type of anion. And in the case here, this will end up being a complex ion. When we look at these reactions, we will always look at synthesis reactions for the creation of acids and involve one of these combining with one of these to make one of these so that it's very, very predictable. The last scenario we can look at for synthesis reactions is looking at a metal oxide. So something like, say, sodium oxide, magnesium oxide, calcium oxide, some metal with oxygen as a compound. And if we react it with water, we end up with something called a base. Now, we haven't really studied the characteristics of basic compounds, but for the purposes of these reactions, all you need to know is that they are some sort of metal cation that combines with hydroxide. And that's the definition of a base that we will use for this purpose. So let's look at some examples to see how these work. So again, synthesis reactions, as you can see, involve two or more things that come together to create one larger molecule or one larger compound would actually be a better word to put there instead. And so let's begin with a couple of sort of non-metal examples. Let's look at hydrogen and oxygen producing water. And here we have a word equation that we can put into a chemical equation. As we do so, we recognize that hydrogen and oxygen are members of Gerber's group of 7 or Hofbrinkel, whichever way you wish to remember that acronym of elements that exist as diatomics. And so we would write an equation that looks like this. We would say H2 plus O2 produces water, H2O, or you could write it as HOH as we did in the previous slide. From a structural standpoint, you can see that we could draw some representations of those molecules from the molecular model kit experiences that we have, and it will look something like this. However, we can recognize that this equation is not balanced. And if we examine the hydrogens to start, we notice that they are balanced on both sides. There's 2 on each side. But for oxygens, they are not. So if we take this one and we clone it, we would now have two reds on each side. The number of hydrogens has increased though to 4 on the right, so that necessitates cloning one of these on the left, so that we end up in a balanced equation of having two H2s and one O2 producing two waters. So you can see the nonmetal plus the nonmetal produces the molecular compound of water. Let's look at how synthesis reactions work with metals and nonmetals. So iron being a metal element, oxygen being a nonmetal element, produce an ionic compound, iron 3 oxide. We could write a chemical equation for this, and you could pause the video and try it first if you like before revealing it. We'd have to remember again, oxygen is one of those elements that is a diatomic. And so when we write the chemical equation from those words, we end up with something like this. We could represent this structurally. Oh, let's try that again. Delete. There we go. Maybe something like this. And we notice that in this combination that iron has given off some electrons to oxygen. Oxygen becomes oxide, iron becomes a cation, and they combine in a 2 to 3 ratio. However, again, this equation is not balanced. So we could begin with, let's say, the irons we could double this iron to make them equal on both sides, but the oxygens are a little off. So 2 on the left and 3 on the right means that the lowest common factor for those two numbers would be 6. Means I'm going to have to increase this one up to 6, and I would have to increase this one up to 6 by cloning it once. That will affect my irons. I'll have to add a couple of more. It's always nice to leave these single elements till the end for balancing, because you can make as many of them as you need to make things happen. And so we see then that the final balanced equation becomes 4 irons reacting with 3 O2s to produce 2 Fe2O3s. And so again, metal to nonmetal can create an ionic compound. Now, synthesis reactions can also occur between an element and a compound, but we can't predict things very easily when we do so. So for example, carbon monoxide and oxygen can make carbon dioxide. If we take a moment to write the chemical equation for that, we see it would look like this. That one's fairly easy to maybe predict because merging those two together would yield something very common, but you might stop and think, well, one CO and one O2 would make CO3. And again, not everything goes together in a one-to-one reaction, so it's not easily predictable. Nonetheless, let's continue with this one and attempt to balance it as well. So we notice that initially we have more oxygens on the left than we do on the right. So let's increase the number of oxygens on this right-hand side by cloning it. You'll notice now we have 4 reds on the right, only 3 on the left, but we also have 2 carbons on the right, which necessitates creating 2 on the left. And so if we clone that one, we see now that there are equal numbers of carbons and oxygens on both sides. And it took 2 of these reacting with one O2 to produce 2 CO2s. So the merging of 2 compounds together to create a larger compound is not one I would expect you to be able to predict products for, especially 3Us, but you could recognize unless that it is a synthesis reaction. There are a couple of synthesis reactions, though, involving small compounds that we can predict with certainty. And we will look at how acids and bases form from their respective oxides reacting with water. So acids, as we said at the beginning, come from non-metal oxides reacting with water. So sulfur trioxide here would be classified as a non-metal oxide because sulfur is a non-metal. And water, of course, being H2O, we could create an equation for this. So we have sulfur trioxide and water. And as I mentioned at the beginning of the video, we're always going to make an acid. Acids always have H plus in them. And what I would expect you to be able to do, especially grade 11s, is to take whatever isn't hydrogen and merge it together to create the complex ion. I'm not going to give you any examples where they don't perfectly merge in a one-to-one reaction. There are many that do, but you can't predict that with certainty. So you can see that those make SO4 2 minus. But of course, in order for the charges to balance inside that acid, we need to have 2 H's instead of just 1. So it's a simple merging of everything that's non-metallic to create that complex ion in the acid. For bases, we're going to create them from metal oxides. So calcium oxide is an example of that because calcium is a metal. So if we put calcium oxide and water together, they make calcium hydroxide because in the beginning, I suggested that bases contain OH in them as their anion, and that's what defines them as a base. So the OH, you can assume, comes from water and any other oxygens that are in that oxide, and then therefore that leaves whatever remains here to be the cation that goes with hydroxide over here. And you'll notice that in this balanced equation there are 2 hydroxides to 1 calcium because calcium does form a 2 plus ion, whereas hydroxide forms a 1 negative ion. Okay, so again, 2 things merging into one, but in a predictable way. So to summarize, all synthesis reactions can be easily identified by inspecting what's on the left and on the right. And if you have 2 or more reactants that make one product, one larger compound, you know you have a synthesis reaction by inspection. So grade 12s, you are expected to be able to just identify reactions by their type by looking for some of these characteristics of 2 reactants or more on one side producing one, whereas grade 11s, you'll need to take it a step further and you need to actually be given reactants and try to be able to predict what the product is with some accuracy and knowing some of the patterns that have been outlined in this video.